Okay, in this video I am going to be going over how you find the epicenter of an earthquake using time and data along with your PNS wave graph. So when you get this assignment, first thing you should do is read through the information on the front page. It gives some information about P waves and S waves for you to read that could possibly be on the test. So make sure you don't just skip this page, make sure you read over the information. We're going to start on the inside of the packet. And we're going to start with part 1. So part 1 is all about determining P and S wave travel times. And it says, using this image in your ESRT, answer the following questions. Well, you don't have an ESRT, but what they're referring to is this graph, this P and S wave graph. And so in order to answer these questions, we have to understand a little bit about how to interpret this graph. And so we're going to talk about scale so you understand what the tick marks or the lines represent before you get started. So this is a graph of P and S wave travel time. So if we have an earthquake that happens at this 0, point, the P waves and the S waves both travel at the same time, but they travel at different speeds. And so the P wave is a primary wave. It goes the fastest. This is its travel time. And so the travel time is in seconds. And we have the distance from the epicenter down here. You're going to notice it says times 10 to the 3rd kilometers. So the reason that I mention that is this 1 is not 1 kilometer. It's 1,000 kilometers. This is 2,000 kilometers, all the way up to 10,000 kilometers. So you might want to write that on your paper. If you give me a 1 kilometer on a test, you would get it wrong, or a quiz. Then we have these tick marks. So every mark in between indicates a different scale. So if this is 1,000, we've got 1, 2, 3, 4, 5 tick marks. So if I take 1,000 divided by 5, that's 200. So every small line on here is going to be 200 kilometers. So I'm just going to write it there to help me remember that. On the time side, we have minutes, 1 minute all the way up to 24 minutes. And with the 1 minute, we have 3 tick marks, 1, 2, 3. So if I take 60 divided by 3, each of these little marks is going to be 20 seconds. Okay? For the first part of this activity, you are going to just get comfortable with utilizing this graph. And so all of the questions are, it'll either give you an epicenter distance or a time, and you're trying to figure out the other one. So if it says you're this far from the epicenter, how long does it take for a P wave to get to you? We could find our distance and then go up to our P or S wave line, whichever one we're looking at, and then go across to find our time. If it asks how far we are based on time, I can go to the time, come across until I touch the line, and then go down to figure out how far I am from the epicenter. Okay? And so that's what you're going to do in this first part. So it says part 1, numbers 1 through 6. So let's do number 1 together, and then I'm going to have you do the rest on your own. So it says, how far will an S wave travel in 14 minutes? Okay, so I'm going to pull up my graph. I'm going to find 14 minutes. I'm going to go to my S wave because that's what it's asking for. Then, once I find where it is, I'm going to go down. And it's right here. Okay, so that's 4,002 for 600 kilometers. So on my paper, 4,600 kilometers. That unit is really important, so make sure that you don't leave that out, okay? You can go ahead and pause the video and do numbers 2 through 6, and then when you're done, you can play the video again, and I'll give directions on how to do part 2. Okay, in part 2, what you're going to be doing is it says using time differences to calculate epicenter distance. So if we know the difference in time between when the P wave and the S wave get to our location, we can figure out how far we are from the epicenter. So how do we do that? So we're going to do this first one. It says 8 minutes and 20 seconds. So what I'm going to do is take a piece of scratch paper. So it's a little easier to see in the video. I'm just using an index card. I'm going to put it so that the corner of my paper, or my little scratch paper, is right at the corner of my graph. And then what I'm going to do is I'm going to make a mark at where 8 minutes and 20 seconds is. So I'm just going to move this over just a little bit so I can see the tick marks. And I've got 8 minutes, 20 seconds, okay? And I'm going to write that here, 8 minutes and 20 seconds, because eventually I'm going to have more lines on here. Then what I'm going to do is I'm going to take this and I'm going up my graph. And what I'm trying to do is find the spot where the corner of my paper touches the P wave line, and the little mark I made at 8 minutes and 20 seconds gets the S wave line. That will tell me how far I am from the epicenter. So I'm going to slide. Oh, that one looks kind of close. I'm going to move down one just to make sure. That looks like it's a little bit better fit. Okay. If I wasn't sure, I could slide it up again and, maybe go up one more. That's what I do a lot of the time, just to make sure I've got the best fit. So that looks like it's the best fit. See how my corner of my paper is touching the P line, and that tick mark is touching the S wave line. Then I'm going to go down, and that's at this location right here. So that's 6,246,800 kilometers. So on my paper, 6,800 kilometers. Okay. Now, these can be a little bit off. Within 200 kilometers would be fine on a test or a quiz, but we want to be as precise as we can with these measurements. So what you're going to do in just a moment is you're going to pause this video. You're going to finish filling in the data table. And then on the next page where it says practice, there are a few more questions to practice where they're written more like a question rather than just putting data in a graph. So you can go ahead and pause the video, do part 2. When you're done, press play, and I will explain how to do part 3. All right, for part 3, we're going to add another step. So we kind of do this in baby steps. Every time we add another step. So with part 2, when seismologists look at time data, they use 24-hour time. If you're not familiar with 24-hour time, let me turn this over and I'll explain. So with 24-hour time, 8 a.m., we don't want a.m. and 8 o'clock p.m. Instead, 8 a.m. would be like this. And in our example, we're going to have hours, minutes, and seconds. If we wanted 8 p.m., once we get past noon, we're just adding an hour. So, for example, 1 p.m. would be 1300. So if I keep going, that's 13. When we get to 8 p.m., that would be 2000. Okay? If we're doing minutes and seconds. Okay? You can look up stuff on YouTube if that's still not making sense. But that's how we do time. So in order for us to get information like this time difference between the P and S waves, if we have time data, is we have to be able to subtract time. And so that's what we're going to practice here in the boxes. So it says subtracting time, sample problem 1. We're going to put in 2 numbers, 11 minutes, 34 seconds, and 50 seconds. 34 minutes and 50 seconds. And we're going to subtract 6 hours, 27 minutes, and 10 seconds. And it's just going to be like regular math. So I can go lane by lane, or I can look at, whole time within that time frame. So essentially we're taking 10 seconds from 50 seconds, which is 40, or we could go 0 minus 0, 5 minus 1. Here, I have a 4 and a 7. Well, I can't take 7 from 4, so I'm going to borrow. 14 minus 7 is 7. 2 minus 2 is 0. And then 11 minus 6 is 5. So I've got the difference between is 5 hours, 7 minutes, and 40 seconds. If I want to double check, if I take these two and I add them together, they should equal this number up here. Okay? The next one's going to be a little more challenging. So I have 11 hours, 14 minutes, and 20 seconds. And I'm going to subtract 6 hours, 27 minutes, and 50 seconds. All right. I can't take 50 from 20, so I'm going to borrow from this. But I'm not borrowing tens, I'm borrowing a minute. So that's 60 seconds. So I'm just going to add this together. So 60 plus 20 gives me 80. So I'm just going to change that 2 to an 8. Okay? So 80 minus 50 is 30. Then I have 13 minus 27. I can't do that either. So I'm going to borrow from the hours here. So this is going to become 10. And that adds 60 minutes. So 60 plus 10 is 70. And I don't have to worry about the zeros. Not going to change anything here. Okay? Now, I could take 73 minus 27. I'm going to go lane by lane. I can't take 7 from 3, so I'm going to borrow. Because we're in the same time, it's only tens here because we're still in minutes. So 13 minus 7 is 6. 6 minus 2 is 4. And then 10 minus 6 is 4. So I'd have 4 hours, 46 minutes, and 30 seconds. Again, I can always double check by adding these together, and they should equal this. One thing that sometimes happens when we're doing this is we might have a number like 2, maybe it's 0 hours, because a lot of our times are going to be in minutes and seconds, and we have 12 minutes and 72 seconds. Okay, well, we don't really have a 72 seconds, so we do need to round up. Take 60 off. That would make this 13 minutes and 12 seconds. Okay, so that's going to be important too. All right, so then what are you doing next? In the next part, you're going to do the same thing as you did before. So we need to find the time difference. So if we take the S wave time and we subtract the P wave time, that'll give us our time difference. And then we can use that with the graph to find the distance to the epicenter. For the next part down here, I'll explain and then you can work on both parts. If I know, here's what time the P wave got to me, here's how far I am from the epicenter. I want to figure out how long it took the P wave to get to me. So I take these numbers and I use my graph. And all I'm going to do with my graph is I know how far I am away. I'm going to go up and figure out how long it takes the wave to get to me. And I'm going to put the time here. If I know the time and for this, if I take the P arrival time and I subtract the P travel time, this will give me the time of the earthquake. All right, and there you go. Let me know if you have questions.